Hello everyone. Today we are going to talk about geometric features of surfaces of different structures with various cross sections. I will show you how to calculate these features using the following exercise. We have this cross section here and we have to calculate the following parameters. Centers of mass, moments of inertia, and the strength moduli. It's very important to take into consideration the parameters order that I've just mentioned. We will begin the centers of mass calculus, and the first step to do that is to split the cross-section of the structure in simple geometric shapes. We insert the z and y coordinates as shown, and split the surface in 3 rectangles like this. After this step, the next one is to point out every center of mass of the resulted rectangles. Now for each rectangle we will calculate the area and the coordinates of the center of mass relative to the coordinate system drawn previously. Here every z is the distance between the y-axis of the entire cross-section and the center of mass of rectangle 1, 2, or 3, and every y is the distance between the z-axis of the entire cross-section and the center of mass of every rectangle. We will name the centers of mass of the entire surface y sub g and z sub g. In this case, we have a surface with an axis of symmetry, therefore the y sub g will be 0, because the center of mass of the entire section and the centers of mass of the 3 rectangles are collinear. Another important thing to mention here is paying attention when calculating the area of rectangle number 2. When there is no hatch in a cross section, that means we have to subtract that value of that area from the geometric shape total area. Now we can calculate the z sub g and the y sub g for the entire cross section using the following formulas. After finding out the values of z sub g and y sub g parameters, the centers of mass calculus is done. Next, we will calculate the moments of inertia, named I, relative to y and z axis. We'll start with the moment of inertia relative to y-axis. We will use the following formula, and now I will briefly explain every component of this formula. The first component is the sum of all moments of inertia of every single geometric shape in which the cross-section was previously split. The formula used for calculating the moments of inertia for a rectangle will be this one, where b is the base of the rectangle and h is the height of the rectangle. In this second component, we know every value of these parameters because we calculated them in the previous step. Now to calculate the moment of inertia, we'll just have to replace all the parameters we know in this formula. Here the numbers 1, 2, 3 correspond to the numbering of the rectangles, and y also corresponds to the numbering of the rectangles. Now to calculate the moment of inertia relative to z-axis, we'll use this formula, where again b is the base of the rectangle and h is the height of the rectangle. Because this entire surface has an axis of symmetry, this component will be 0. We introduce the known parameters and the calculus of moments of inertia is done. The third and the last step is the calculus of strength moduli. Here we will apply these simple formulas. We replace these parameters with the known values and we are done. Last thing to mention here is that y sub min is the distance from z-axis of the entire cross-section to the closest fibers, and y sub max is the distance from z-axis of the entire section to the farthest fibers of the section. Thanks for watching, and I hope now you have a clearer understanding of geometric features of different surfaces.